All right, in the last lesson, we learned a quick way to find a percent of a total. In this lesson, we would like to develop and understand methods for increasing and decreasing a number by a certain percent. We will start with the increasing part. So exercise 1. Agronomists are studying how quickly the population of an invasive species of beetle will increase in a controlled farm setting. They calculate that the population is increasing at a steady rate of 6% per week. At the beginning of the week, the population was 350 beetles. So the information we know, 6% per week started at 350. So we need to find what 6% of 350 is. Keep in mind, the word of means multiply. So 0.06 times 350, and a calculator will quickly tell you that is 21. So it increases by 21. So we're going to add it to the original population, and it's 371 beetles a week after. So find the population of beetles a week later by a single multiplication. So what if we do 350, right, plus 350 times 0.06? We end up with the same thing as 350 times 1 plus 0.06. Because what we did is we took this whole thing and we did it as if, so we're looking at this as if it was a distributive property. So we're going to undistribute it. So they both have 350 in common, so I can take a 350 out, and then I'm left with 1, which is 350, plus 0.06. So this is the same thing as taking 350 times 1.06, and you end up with 371. This works for everything. So if you want to find how much tax would be of something, instead of multiplying it by 0.08 for 8% tax, you would multiply it by 1.08 so that you wouldn't have to do an addition later to add it to your original total. Kind of silly, but I'll show you more later. So what will the beetle population after 2 weeks be? Well, we take after 1 week and multiply it by 1.06, and we find 393.26. But you cannot have 0.26 of a beetle. So it rounds to about 393 beetles. So the ability to increase a total by a certain percent using this method is important. Get some fluency with it in the next problem. So this is what I was just talking about. So we're going to increase 440 by 12%. So we're going to take 440, and instead of multiplying it by 0.12 and then adding it later, we're multiplying it by 1.12. And this gives you 492.8. I want you to try the next few by pausing and then checking the answer when you're done. So 68 by 1.08, and you get 73.44. And our last one is 120 by 3.5%. So 120 by 1.035, and you get 124.2. So Adriana has a saving account that promises to increase her balance by 2.5% per year. If she deposits 720 in it at the beginning of the year, which would be her balance at the end of the year? So we're going to use the information we know up above. So we're going to multiply 720 by 1.025, and that gives us 738. So $738 is how much more money they would have at the end of the year. We would also like to work with decreasing by a certain percent. This will follow a similar, if not identical, pattern to the increasing one. Again, let's understand what is going on with an introductory problem. So a cup of coffee is cooling down such that its temperature is decreasing at a constant rate of 8% per minute. Let's say the coffee starts at 200 degrees Fahrenheit. So we need to first find 8% of 200, which is 0.08 times 200, which is 16. So we take 200, because that's where we started, subtract 16, and it becomes 184 degrees Fahrenheit. So that's after 1 minute. So if we want to do a single product like we did before, we had the original and then the original times the percentage, and we added. But since we're decreasing, we're going to subtract. So if I undistribute this, it becomes 200, which they both have in common, times 1 minus 0.08. Well, 1 minus 0.08 is 0.92. So 200 times 0.92 gives you 184 degrees Fahrenheit, which is what we see up above. So what will the temperature of the coffee be after 2 minutes? So we're going to take what it was after 1 minute, which was 184, multiplied by 0.92, because again, we're taking 8% off 100, and we get 169.28. If we are looking at a percentage, this becomes 169 degrees Fahrenheit. So decreasing by a certain percent is an important skill to be fluent with, as well as increasing. But it's harder for you to think of because you have to think of what percent remains. So the enrollment of students at a school is decreasing at a constant rate of 5% per year. So we have to think, what is 100% minus 5? It's 95% will remain after 1 year. So if the population this year is 2,300, what will it be next year? Well, we multiply that by 0.95 because that's what remains, and we get 2,185 students. So many of your answers are going to involve decimals, obviously. Do not round. Write the calculations you use to find your answers. So we're going to find 620, but we need to decrease it by 10%. So what's left once we take away 10%? 90%. So 620 times 0.90 is 558. We're going to take 2250, and it's being decreased by 8%. So what's left is 92%. Multiply those, and we end up with $20.70. And finally, we're going to decrease 122 by 3.5%. This might take a little bit more math to do, but you end up with 96.5%, so 0.965, and it becomes 117.73. Finally, the cost of gasoline has decreased recently by 4.5%. If it started at $3.80 a gallon, which of the following is its price after the decrease? So again, what is 100 minus 4.5? Well, 100 minus 4 is 96. So minus another 0.5, and we get 95.5. So 0.955. We multiply those, and we end up with 3.629. So $3.63 per gallon.